Everyone I know that had 3 or 4 boys at home, someone got stabbed, or someone got shot, or they burned down the garage or backyard.
Yeah, unless my father had a very kind hand. That's the other solution. Like you very quickly physical boundaries, which is its cost. Right?
And my rule, I mean, I had a boy that girls wasn't as crazy, but I remember when I wasn't busy, I was cook. So my rule was like, I'm be busy all the time. You have no time to do anything.
Yeah, my wife's doing this with my daughters. That works pretty well. Daughters are easier, or you know it.
Yeah.
Right?
Well, it's a different.
Yeah, it's but you could they understand boundaries without basically physical restraint. Yeah, we know what I mean, right? Like,
Chain them to the bedpost.
yeah. It doesn't necessarily have to physically hurt, right?
Yeah.
So I ended up with 1 or 2 conversations with one of my daughters. She started to physically hit my wife. Around 14. It's just, it builds up, right? She first touches her, and you know how these things like evolve, right? And she's built, Ukrainian way. My wife is like a slim German figure, and she woke me up. Like golf, so shoulders like me.
Oh,
right?
she's the golfer.
Oh, yeah. I told her. So at a certain point down, I had to sit her down, and it was instead like, no, we're on the wrong page. Yeah, this is how this discussion works. And the consequence will be such that at a certain point in time, I'll have to pull this car take you over.
Yeah, exactly.
And her eyes were like,
But then you have to execute what comes down.
oh yeah, well, she knows that. Her childhood memories,
Come on up, front row. It's all yours.
and you get to do the paper and the notes. Thank you.
That's our time. We're on, right?
I suspect that there is some string attached to this thing.
Well, you were wrong. You were wrong. There's not one string.
Okay.
It's 2 minutes late.
My social is late, man.
Shut the door. Release the hounds. Welcome to Bier. We are at the time. Whoa, I know that guy. How you doing? Oh, can you still spell Pim? We've all forgotten.
Excuse my culture. Medication. We're still working on.
Can someone go back there and shut the door toward us? Appreciate it. Thank you. All right, welcome to Bier. I'll bring the slides up here in just a second. Before we get rolling, as always, we need someone to take notes for us. We need a minute taker. And as cruel as I am, if someone makes eye contact, you get selected. So I was looking down, reading an email. I saw that. I saw eye contact. Nothing. Someone please help out here. It's a great way to participate, contribute. We'll sing songs about you and tell stories. It'd be legendary. I heard someone. What'd you say? Someone volunteer? Are you willing to take minutes for us? Oh, fantastic. All right. If you could take minutes as well, you'd be our best friend for the day. Thank you very much. All right, we got a minute taker. All right, I'm going to get this hot. Worked. that's gone, and that's gone, and I'm turning this off. Boom. We don't have the projector even on. See it on both screens?
I hope this one fired up, yeah?
Fire up.
Uh-huh.
There, it's coming.
Okay.
I have both.
We have an AV guy in the room.
AD? No AD, we can do what we want.
We didn't hear it yet?
No, we can do what we want.
We can do whatever we want.
That's up to me, man.
I'll say Tony made me do it.
Birdie down now.
All right, welcome to Bier. Everyone in the right room? Look at that,
Plus one.
+1. Yeah. Okay, busted. I used the same deck and edit it. You caught me there? All right. I got the date right though, right? Today's the 14th?
I told you it will happen one day.
Yes.
Close enough. All right. Welcome to IETF 199. No slideshow. Note well. Noted. Nods. Excellent. We have a minute taker. We have someone on Jabber. We got a Jabber scribe. Can someone hop on Jabber? Is someone on Jabber? Can someone spell Jabber?
Someone will get the sticker for it.
You get a sticker.
It's beautiful.
You get a sticker.
Yeah, we have beautiful stickers.
Can you get on Jabber?
Uh,
We need someone on Jabber. We'll get questions coming up. We need to respond to those questions for remote participation. All right, we got someone here. Tony's on it. You guys got lucky. All right, here's our current agenda. We've got some new items, some existing items, some things that have already been called to list. And then at the end of this, we'll have some time to discuss rechartering, some status going forward, and hopefully have some good dialogue in the room, which is something I like to do. Anything missing from this list? Yeah. And you're not 100 either. You're only 99? So, okay, actually, we had 3 misspelled names that autocorrupt attacked, and I can't blame autocorrupt for this one. This was my fault. Sorry. Torless, yes. When we get to chartering discussion, we'll discuss rechartering. Yes, it's on that piece. You and I talked about it already, so I don't think we needed to bring it up now. That's all right. Anything else missing? Anyone's name I can misspell? Anything I can butcher here? Numbers I can get wrong? Dates? Okay, welcome to PIM. Come on, that was a joke. That didn't go anywhere. All right, so first up is ICE.
Good afternoon, everybody. So I'm Ice from Cisco, and I'm going to talk about this draft. Next slide. So as probably most of you know, so we had that extension discussions about encapsulation, right, some time back. MPLS versus non-MPLS, and what do we do? And we first defined MPLS encoding, and then we did still pull in the non-MPLS encoding. For us, it was always the goal to make those 2 encodings, the same as possible, as much as possible, right? To make hardware not to have 2 different things. So that was, one of the big goals for encapsulation. I think we succeeded in that. So we do have MPLS and non-MPLS specific encoding in the draft. So we're not going to talk about that further. Next slide. So there was still one open issue that Xiao, has been after for a long time. And that is the desire to have static assigned BFITs. Now, we always sort of push back on that because we didn't really want to overload the data plane with too many arguments like, set identifier, subdomain, bit string length, because these should not be properties that, hardware should actually have to look at. So that's the reason why we actually, we're sort of, didn't want to do that. But still, there is, for the non-MPLS encoding, there's still, a good requirement to have such a feature that you can statically define the BIFT IDs and not dynamically do them. So we believe in this draft to actually find a good way in how to do that. So you can still statically define your BIFT IDs without actually overloading the data plane with to know exactly what it is. Next slide. And this is how we do that. So the BIFT ID is 20 bits in the encoding. We're just gonna overload those 20 bits, and we're gonna hard code bit string length, subdomain, and the set identifier in there. Now, what's really important is that for the data plane, they should not actually look at those values individually. They should just look at this as a 20-bit value, do a lookup, and find the BIFT ID, right, and do your forwarding. So that's why we really say, in this draft that the data plane must not parse this field. That would be wrong to do. Next slide. Now, so some of the benefits of the static BIFT ID is that if you hard code it, then there's no need to advertise this. So that does simplify your network quite a bit. Also, it's a globally unique value, so it's also a bit easier to troubleshoot, right? That's what you see like in the segment routing area. They do that as well. Having statically defined labels so they're the same from hop to hop. So it's a bit easier to troubleshoot and follow the path.
Name. See if there's a switch on that.
That will be my name.
All right. That was a solution I had too. It was great. It was a power switch.
Thank you. Greg Mirsky, ZT. Clarification question. Globally unique or domain unique? So is it Bier domain unique or it's globally unique like IPv6?
No, it's domain unique.
Okay, so then please.
Yeah. Okay, sure. Yeah.
It's a huge difference.
Yeah, good point. Yeah. Next slide. Now, so how to do that? Because discuss this among several people for a bit. Because in a way, you can put any value into this 20 bits, and the question is like, well, do you need to write a draft for that? Now, we still think it's good to do that because you can still, encode those values into different places in those 20 bits. So we still think there's value actually in documenting how to do that, so different vendors are interoperable when doing it. Right? So for that reason, so it's an informational draft, so we're not asking for any, INA code points. It's just to make sure that different vendors that use this mechanism can do it the same way, so they're interoperable. Next slide. That's it. Any questions?
If it's not standardized, and there, Charles Eckert, if it's not standardized, how do you get interoperability?
No, we are standardizing it through an informational RFC, right?
Right, but I mean, there is the, how would somebody recognize that this has been used? That would be through some standard header, right?
Yeah.
And that would need an IANA allocation or not?
No, we use the same header, right? It's the same 20-bit field that has to be unique in the domain. Right? You want to have the same way of encoding that value.
Sandro here. Nokia. I think Ecker was saying is how the far end knows that what's carried is actually this encoding versus that. Is that what you were going through? Like the encoding and when I as a router receive that, how do I know that the field actually has this encoding? That was just to clarify the question. I don't think you answered that.
So I didn't get it.
No, like the fact that two implementation understand the encoding, it's step one. The second step that I think is missing is how when I received a Bier packet, and how do I know that it actually encodes that and not carries some?
But that's by configuration.
Yeah.
Right. So there are two possibilities. Greg Mirsky, ZT. Wow, that's sensitive. One is designate some range of 20-bit values that happen to be the same size as MPLS label. The second one is to make a requirement for the Bier control plane to advertise them as distinction.
So you can advertise them, right? But if you statically configure this in a network like this, then you don't.
I think the answer was what you were saying last. It's by configuration.
Okay. Sure.
I just think it's worth adding this. The other method would work as well, but I think it's worth just stating. It's informational, but it's still worth setting so people don't wonder, oh, what's happening? Is it left? Did I miss something?
Yeah. Obviously, we like comments on the draft from you. So if you can post them to the list, that would be great. Yeah. More questions?
Yes. As chair, is your interest then for adoption?
Oh, absolutely. Yeah.
So who in the room has read the draft? How many of you then think this is something that we should adopt in the working group as an item? Okay. Anyone think this should be kicked to the curb? All right. We have solid consensus in the room. Take that on the note, and we will take it to the list. Thank you. All right. Next up, big delete.
So, Human with Goli Nokia. I'm here to present the PIM signaling. This draft was previously called PIM tunneling. It was creating some confusion because of the name, so we changed the name of the draft from tunneling to signaling. Since then, we got some feedback from Jeffrey and some other players. I'd like to thank you for that. I tried to upload the new draft with the name of the people that contributed to those feedbacks. Unfortunately, I was a little too late, so on the next one, definitely those names going to be there. So from problem estate point of view, obviously Bier is a great technology, and we are seeing a lot of traction for Bier throughout different providers. One thing that keeps coming out over and over again is the fact that how we can, if it's not a greenfield deployment of the Bier, how we can kind of interconnect Bier to some of the legacy MVPN or PIM type of services. And this is what this draft is trying to solve. So basically, most of the providers out there, they have multiple BUs or multiple segments of the network, core, access, etc. And what we are seeing right now, the traction is that they want to upgrade their core to a next generation core where they call a clean core or a lean core, or they need a single IGP protocol. They don't want to make the core too complicated with multicast protocols, whether that's PIM, IGMP, or any other MPLS type of protocol, which is MLDP or point-to-multipoint RSVPT. They just want to run one single protocol, IGP, and make multicast work on that. Obviously, Bier comes in very nicely in that lean core, but when it comes to the access, where they have fixed networks or mobile backhaul wireless networks, they need to somehow stitch this type of network to the clean core. And this is what this draft is trying to solve. Next slide, please. So here's a typical network, one of the example of the network that we see. So as you can see here in the core, we have Bier, and it's only Bier with IGP. On the access, we have PIM domain. So on the PIM domain, all the routers, they talk PIM with each other, and they actually create PIM adjacency on the PIM domain. That PIM adjacency gets terminated on the Bier boundary router, the BBRs. From that point on, if the BBR kind of determines that the SG needs to go to the other side of the Bier domain, it will signal that SG, whether it's a join or the prune, to the other side of the Bier domain, to the other BBR. That other BBR grabs the Bier packet, removes the Bier header, looks at the signaling, whether it's join or prune, and kind of pushes that signaling back into the PIM domain toward the source of the multicast. So all the changes in this draft, to be clear, is from signaling point of view. On the data path, it's really what we did previously from PIM point of view. So when the source starts sending multicast packets, in this case, in an IP multicast environment, it gets to the BBR, and the BBR just puts it into a Bier header and shoots it through the Bier domain to the access. And on the access, the other BBR removes the Bier header and forwards the packet as it was done previously in a Bier type of environment. Next slide, please. So again, to sum this up, when it comes to the implementation of this, we are not trying to reinvent the wheel. There's already RFC out there, 6826, which is in-band MLDP signaling, which is basically doing the same thing with PIM and MLDP. And we are trying to bring that technology into the Bier domain also. It's nothing new. It's not I guess, a new wheel invention. All the changes are from control plane point of view. As I mentioned previously, I'm not going to go through it again. And when it comes to the ASM and SSM, at the moment, we are concentrating on the SSM. From ASM point of view, the same thing with RFC 6826. We feel that it's just going to work. Whether there's going to be some corner cases or not, we need to investigate that a little bit further and see what we need to do from the ASM point of view. Next slide, please. So from the Bier header point of view, from signaling point of view, there's not much changes. One of the changes that we did from the previous draft is we changed the protocol. Again, thank you, Jeffrey. From PIM protocol to IPv4 and IPv6. I think the reasoning behind that was that on the BBR, when we get the Bier header, we need to examine the payload anyway. So when we examine the payload, we realize it's a PIM packet given the IP protocol or the destination, the multicast destination IP address. So we extract the PIM packet, signaling packet for processing on the corresponding module, if you will. So nothing new here from Bier header point of view. Next slide, please. So again, one of the things that we kind of had discussions with was how do we determine where is the other BBR, which is on the path to the source. So if you will, when the PIM signaling comes to the ingress BBR, somehow it needs to figure out what is the next BBR that is closest to the source. We feel that there is a lot of way to solve this issue. At the moment, the draft has left it wide open how we can solve this issue. Going forward, there are some ideas and discussions that we're going to implement or we're going to put into the next version of this draft. But just to give you some of the example, if it's a single IGP area and Bier kind of, the Bier edge router, they kind of flood their Bier ID through IGP to every other Bier router out there, then we can actually use CSPF type of calculation to figure out where the BBR edge routers are when we are trying to resolve those. Another idea is that if the Bier boundary router is ABR, which is generating the route, aggregating the routes, we can use the source field in the IGP TLV, if you will, to actually resolve that BBR. Again, there are other methods to do that, static routes, IBGP. So this is one of the areas that there can be many, depending on the provider, there can be many ways of resolving that BBR. And as I mentioned, on the next draft, we're going to have more details on it. Next slide, please. So at the end, some of the things that this draft will solve is obviously tries to bring Bier in the already existing multicast environment, which is non-greenfield deployment in incremental matters, starting with the core, and eventually they can evolve to the access. Another thing is that it's going to solve the multicast states that we are seeing in some of the larger operators out there in the core routers, when it comes to the multicast states and OFIs. Obviously, as these networks are growing, we are kind of running out of resources to have all these OFIs and multicast states. And the last thing is, I guess, from the BGP point of view, because you remove the need of the BGP in the core of the network, a clean core, then when it comes to the BGP address family and RIPs and so on, your core becomes offloaded. So you can use that memory for other type of implementation that the router needs. I think that's all I got. Any question, comments?
Jeffrey from Juniper. Can you go back to the last slide? The last point, Bier boundary router will be offloaded from managing BGP addresses. Can you elaborate on that one?
Sure. So as I said, to figure out where the BBR is, there are many methods to do that. So some of the operators that we talk to, they just want to run a single IGP in their core. They don't even want to run BGP. If they run BGP, that means they want to run MPBGP between PE to PE because they're doing draft ROSN or some kind of MVPN type of service. So in that case, because BGP is between the two end routers, then in the core, the BGP packets are just any IP packets, and those BBRs, they don't need to track the BGP, if you will, RIP or FIP for that matter. Does that make sense? Or maybe we can go to another slide. I can explain it a little more in detail.
Well, it's hard for me to make that connection now. Is it that if you are saying that instead of using BGP as the overlay signaling protocol, you're just using PIM itself, and that's why you're saying that?
Yes.
Okay.
Yeah.
Okay. Can you go back to slide number 3?
2?
3, yeah. So in this picture, assuming that those PEs are ROSN MVPN PEs, and so there will be the provider groups, and so you are using Bier to set up those provider trees through that link core. Now, imagining that the Bier core can actually go all the way towards the PEs. So in that case, I think the same mechanism can be used directly for the overlay signaling. So basically, you can just do today with ROSN MVPN, you essentially have PIM joins in the overlay between the PEs. And now I think you can use Bier to carry those PIM signalings in overlay. So what I'm trying to say, you could make this mechanism generic so that it can be for both the provider tunnel signaling and for the overlay signaling as well. So if you could make that generic, then it will be good. And also, when you do that, it's actually there is a very well-defined mechanism for the PEs to find the upstream PEs in the ROSN MVPN case already. That goes well with your slide number 6 there, I think.
Okay. Yeah. Yeah, that sounds actually right.
Hi, Cisco. So we had some offline discussions on this before the meeting, right? So
Yes.
It was good. So just to maybe for the record state maybe a few things that should
Closer
be
to the mic.
updated. Yeah. So just want to state for the record a few things that we talked about. So so discovering the BBR is key to the whole solution. So that was my point that's not out of scope, right? So although the mechanisms need to be well defined so everybody knows how to implement. So the one minor concern, and that's maybe a few Unicast guys can maybe pitch in here. So one of the solutions is to use the originator of the LSA, right?
Yes.
As to figure out that is the BBR, right? By
Yes.
re-injecting doing summarization. So the guy who advertises summarized route, that originator ID is used as for routing as to figure out what the BBR. I'm not sure if that is a new way. I've never seen that used before. In my opinion, that was always like informational, you use for troubleshooting and not for routing. But if there's other use cases where it's used for unicast, then that's completely fine with me. But it's maybe good to check.
Yeah, definitely. As you mentioned, we're gonna make this a little bit more clear in the next draft. And just to comment on the source of the IGP route, I believe today we use it for unicast for segmented routing. But yeah, makes sense.
Just kind of, again, for the record, what we discussed, Andrew Dolgano, sorry, Nokia, what we've discussed with ICE. The original intent to keep this problem out of scope is because we do recognize that there is multiple ways of doing that. And the idea was we did not want to mandate a way. So we will add the section that will talk about various mechanisms. It will be recapture of mechanisms and not standardization of new mechanisms, to be clear. If anybody wants to have their own way and propose a text, we're happy, and we don't care how you find the other way, as long as it works and doesn't reinvent the wheel. We don't want to do that. And so just for a record, again, recapture this, why it was out of scope and why it's now moving into a scope per se.
Thank you.
Stig Vanas. So one slightly related issue. So we've been thinking a little bit about Bier DF election, right? And if you have Bier all the way to the edge, try to do some DF election to find out which router on the source LAN should be the Bier forwarder. And one problem related to this is, in this case, you don't know who is elected the forwarder. You just send a PIM join based on your shortest path or whatever. Another thing is, you might end up, if you have two different routers on the edge towards the source, two different Bier routers might join to, each show the two ingress routers. Let's say if you have like routers A and B connected to the source, then one router on the receiver end might join to A, another router might join to B. So both A and B end up forwarding. But you might want them both to choose either A or B. So I think how you choose where to send that PIM join might be more complex, or you may not want to do it in a different way than just looking at the usual kind of shortest path.
Right. Sorry.
So
Name.
Andrew Nokia, do not disagree. However, I would disagree where we should be documenting things like that. That's a general Bier problem. You would think similarly where we didn't define in other multicast technologies, we left to the protocols that do the selection. So this is a problem to have, problem to solve. But is this the place, or should we use this from other places? Right.
Yeah, so I would say, I partly agree with what you said earlier, that you wanted to keep some of this out of the document because there's multiple ways of doing this. And part of my point is that, yeah, it seems obvious to do the shortest path, whatever, but maybe you want to do something else in some cases. So even though maybe you don't want to specify everything in this document, it's nice to at least discuss the problem a little bit, and I see you added some text for that already.
Totally second. So just to reconfirm the problem it's trying to solve, it's only about that, let's say 256 times replication isn't efficient enough. Is that the real problem?
So that's one of the issues. And the next issue is that, as I mentioned, some of these networks, when it comes to how they are operated or how they're engineered, there are multiple engineering departments that are involved in it. So if the core decides to spend some money and upgrade the core to a next generation core which uses Bier, maybe then the access as an example, a wireless access, which is completely a different BU, they might say, we do not want to change our multicast
Okay.
as of now. We might want to have that 10 years from now. So these are the type of problem we are seeing, that
Okay.
one of these BUs, they want to go to the next.
No, I mean, if you really have the PEs are operated by a different department from the Ps, that is very persuasive. So do you have a real example for the first one, for the 256 is not good enough replication? Is there a hard one?
Well, mobile backhaul. So again, some of these operators in mobile backhaul, they can have in excess of 100,000 cell sites.
Okay.
And when you look at, so in mobile backhaul, the multicast is called EMBMS, as I'm sure everybody knows. So when you start doing EMBMS type of services,
Okay.
with this next generation multicast with Bier, well, the replication could be an issue, especially in mobile backhaul when you go to the 5G and you're talking about some of these services with 4K downloading of IPTVs or whatever that they're trying to bring into the market. It becomes a big problem.
Okay. And the way I correctly understand it is that the BGP is actually all the way out, even on your P nodes, right? The edge P nodes, right?
So no, in this case, like BGP, if this is like draft Rosen as an example, BGP going to be running between PE1 and
No,
PE2.
I didn't mean PEs. I meant your edge P nodes.
Carlos,
Yeah.
I'm sorry, read the draft, right? We're running out of time. Let's just kind of stretching this thing on. All right. So I assume the goals adoption. That's the interest here. So who here has actually read the draft? Current form? Excellent. Who thinks this is the kind of work we should be picking up here in the group? Nice. Anyone else think this is to be kicked to the curb? No use? Beautiful. All right, we'll take this as a list. Thank you very much. Next, Bier BFD. You can use it for a pointer, but we don't have the slide progress. Just I'll follow along tight as I can.
Hello. Okay. I'm Fang Wei from JTE, so I will present BFD for Bier. Okay. So the motivation is that so we will define the BFD mechanism. So it's used to provide the verification among the BFIR and BFERs. Okay, so Bier is a multicast protocol. So we think that the Bier BFD should be based on the BFD multi-point draft. So we will use demand model, and this is based on the RFC 5880, and so there is no three-way handshakes. For the BFER, they should use the source address and my discriminator to the multiplex BFD sessions. So for the source address, if the underlayer network is MPS, we think that the source address is the BFR ID and Bier MPS label. If the underlayer network is non-MPS network, so the source address is the BFR ID and BFIT ID. Okay, this is the next. Next is the Bier encapsulation. So as we know that the Bier encapsulation is defined in the Bier MPS encapsulation draft, and if the protocol failed value is 5, so the payload is OM payload. So we will use this OM payload to define the BFD control packet. So we will define the BOM packet format in this document. As the picture shows, we define the wayfared. This is stands for the version, and also the message type. So it's define the OM protocol. If it is BFD, so the BOM control packet field is BFD packet. And also we define the Phoenix field, so it will used for the optional capability. And here we should pay attention that BOM header so can use to the multiplex BOM protocols. So we use the message type. So we think that for the multi-point tail, we don't need to for the multi-point tail do not need the IP UDP port to identify the BFD packet. So this is the BFD encapsulation. Next is this is the bootstrap for the BFD session. So we define the 2 ways to bootstrap BFD session. The first one is one-hop bootstrapping. So we can use the ISS BFD TRV. So this is defined in RFC 6213. And here the next is BFD enabled TRV format. The MTID field is the Bier multi-topology identifier, and the NRP ID. We suggest the value of NRP ID to be assigned as C2 for Bier. So this is the one-hop bootstrapping, and for the multi-hop bootstrapping, we think that we can use the Bier OM pin. So this is the bootstrapping for Bier BFD session. Next, yeah. So comments? Jeffrey.
Jeffrey from Juniper. Since you are defining a OM packet header for this, then that source address, do you want to consider putting that source address field in the header itself instead of relying on the BFR ID? And
I think we can use the source address from the Bier header.
Yes. So since I'm Carl for Greg Mirsky, ZTE, we discussed that, and of course, this is an option and something that for us as a group to discuss, but just trying to be minimalistic. Why? Because it seems as a duplication. So yes, we have not directly address, but indirectly we do know the source of BFD control packet.
I just thought that it would be more bulletproof or future-proof if you put that address in the OM header, because I think right now the BFR ID is identifies the source the BFR, but maybe someday in the future it could be used for other purpose. It could maybe identify something else.
That is very good topic for discussion, because since I'm involved in other OEM-related proposals in Bier, that use the assumption that BFR ID identifies the source. For example, MTU Discovery does that. So if there is some possibility and plans to decouple that, it will be good to have this discussion, and then we can have, take appropriate action in the protocol side. But thank you for bringing it up.
Okay, to the list. So Greg, Tony P. Juniper, operationally, how do we imagine this is being used? So the DMAX is, as far as I see, per subdomain, right? Because you use the BFRID. So you run this per subdomain. Now, obviously, the overlay doesn't use that. Or do you imagine every overlay using their own multi-point BFD? Or is it the operator? But if it is the operator, then how will he know which set to run this BFD2? And how is it different from having the Bier ping, which we already have? So what's the operational model of using this?
Okay,
one BFD?
yeah, the problem with the, I believe that Bier ping and BFD, which is an application of BFD for the multi-point networks, it's different tools. So the ping, again, it's not for the proactive monitoring, in my opinion. It's for troubleshooting. This is for proactive monitoring.
Okay, but who is doing the proactive monitoring? Is it the carrier or is it the overlay? And if it's the overlay, how many of those can you run?
How you can run? Okay, it depends. You know, if we look for development of BFD implementations that originally they were probably software based, and then we got it more and more in a hardware assisted manner, and scaling is enormous. So here I think that it would be interesting question to discuss what really want to monitor and how to monitor, whether it's...
I don't understand. If you're an operator, you want to monitor all the endpoints because you don't know what the overlays need.
I know.
If you're an overlay, how many of those overlays can you run doing each of them independent multi-point view?
Again, I need to point out that BFD for the multi-point or point-to-multipoint BFD does not allow root to monitor endpoint. It's vice versa. It's other way around. It's an endpoint monitors the root because it's unidirectional. And yes, there is an version of BFD with what's called active tails, which will be at least now planned to be published as informational, where the tail can inform the head, which is the root in our case, that it doesn't see you. I don't see you. Right, but
after lots of verbiage, you still didn't answer my question. What the operational model is, but we can take it to the list. That's
okay. I succeeded.
No, not
one
really.
more.
No, not really.
One more.
Come back. No, because this is a good question. Yeah, like we claiming we're gonna have an active monitoring. We've done active monitoring for years, doing different mechanisms, not requiring BFD. If you're gonna start pushing this to hardware, it's not an enormous. If we're looking at the unicast BFD scaling, you know, it did improve significantly, but still it's not enormous. So the dangers with things like this is they become standards, and then people try to. And then we being pushed to implement that for the sake of implementing that, and then extending this for the sake of extending it for every single multicast group in the network. And before you know it, yes, then we have enormous scaling. And by the way, nobody wants to pay for that. So and then people complain that the gear is too complex. So
yeah, no.
But jump in. On the other hand, I have to say that from customer side, Bier OEM is considered as a very interesting property of the technology.
Mm-hmm.
Okay, so the operational model, I think there will be something people will be willing to pay for, will scale, and is good to do. But that's why I'm asking.
Right.
Is that an operational model we want to do? Because I don't think that will scale, just like Andrew said.
Okay, that since we are stating that with this mode of point-to-multipoint BFD, we only able to support egress, monitor ingress, that determines their model. then basically you're monitoring each ingress that you're interested, and then you can have, for example, 1+1 protection, and you can switch to another ingress if you want to. Okay, but I agree that let's discuss it on a mailing list, possible applicability or use of this method.
Okay, Tony P. Juniper, Zujeber asks, please, everyone introduce themselves by name every time because they have a hard time to follow. Thanks.
Okay, Cisco. Just want to make a point about the scale. So today, if you want to do BFD, you have to do it over a per point to multi-point LSP, right? Now with Bier, there is no LSP state, so the scale is going to be better than what we do today, right? Because there's no trees. So it's going to be per ingress and not per tree.
Andrew Dolgano, Nokia. Yeah, the scale will be better, but we're still going to have a.
Please.
I did say Andrew Dolgano, Nokia. I agree that the scale will be better, but we still have a choking point because we attacking ingress. Yeah.
Stigmanas. So, yeah, I mean, imagine if you are doing this in the underlane. Basically, someone wants to monitor the physical infrastructure or whatever in the Bier domain, then they don't really know where the ingress is going to be. And I'm afraid this won't scale if you want to potentially have every single Bier router being a potential ingress router, because then you end up with every Bier router having to monitor every separate potential ingress router. If you do it in the overlay, then you might know who is the ingress router because you know which multicast group you're interested in.
Okay. Okay, just Greg Mirsky, ZT. If that's the requirement, that I would just suggest run a single hop point-to-point BFD and then monitor your neighbor and provide some alarm indication signal saying, okay, I can hear him.
All right, thanks. Let's stop with that one. Clearly, we got some good, robust input on this. Stay up there. Who's next too, I believe. The intent is for adoption. So who's read the draft? All right. Of those who thinks this is work we should adopt here in the working group? Fraction. Who thinks we should not do this in the group? Okay, no objections. We'll take it to the list.
Maybe Andrew Dolgano, maybe one comment, Greg, because like I left hand once, not twice. We're talking here about in some other drafts about extending Bier quite to the access devices. You can have a DDoS attack with that. As soon as you go that deep, you can DDoS attack because you're going from a lot of egress points to an ingress. So I think we need a little bit of a security section.
Tony P. Yeah, and hence, in my opinion, adoption hinges on the operational model rather than just building those things and then people will do weird stuff and require us to support them at insane scale. Okay.
All right, next up. Bier and V6.
Okay, good afternoon. I'm Sandy Zhang from ZTE. The first presentation is for Bier in IPv6. We have co-author Tony. At first, the motivation of this draft is used to environments like HomeNet, maybe some small network. The network may not have hardware support for Bier encapsulation, MPLS, or even support for special Ethernet type. We know that the Bier Ethernet type has not been defined yet. And the native IPv6 encapsulation for Bier hop-by-hop forwarding in pure IPv6 environments could allow to process Bier in the slow path. We know the slow path means some, okay. like a control plane processor. And we know that Bier is simply another next protocol of our IPv6 frame. Next. So the solution is very simple. And let's see the IPv6 header. The destination of the packet we should set to the neighbor's link local address. Maybe we can use the loopback interface address. When we use the loopback interface address, the address should be the same as the neighbor's BFR prefix. The source of the packet should be one of the BFIR's loopback interface address. And it's also should be the same as the BFIR's BFR prefix. The TTL we should set to 1. And the next protocol should be defined to indicate the following Bier packet. The flow ID is a copy of the entropy field in the Bier encapsulation. Next. The Bier header is aligned with the format defined in Bier MPLS encapsulation for a non-MPLS version. So we know that the S and the TC bits have no significance here. And the BIFTID is also the combination of subdomain, set identifier, and the bit string length. The remaining fields are unchanged with the Bier MPLS encapsulation draft. So that's very simple. Any comments?
Jeffrey Dang, 2 questions / comments. If you can afford to do this in the slow pass, could you just do ingress replication?
Ingress encapsulation.
Right.
Oh, it's one way. If you want to use unicast,
Right.
like ingress replication, you can do it. But if you can use multicast, you can use this function. Yeah. So I think the efficiency of ingress replication and the efficiency of this draft may be the same, but in some situations it may be different. So we think that we can provide any ways to achieve the result. So operator or anyone can choose the function. Yeah.
Okay. Next question is, seems to me that there is nothing special with IPv6. It's really like Bier in X.
Yeah, it's we just put IPv6 header in front of Bier header. Yeah.
Right.
it's
It could
simple.
be
Yeah.
put IPv4 header in front of Bier head.
Maybe we
Right.
can
So
try.
Bier in X. Right.
Okay, I have a question from Jever from 192.285.76360. I assume it's I assume it's Julius. Why is this restricted to link local, and what happens if you extend it across multiple IPv6 next hops? I can see arguments both ways. Perhaps you don't want an encapsulation specific tunneling mechanism. Answer is yes. So that shouldn't be used as a poor man's tunneling, because otherwise the packets can show up in random places in the network and loop. So this is a strictly hop by hop mechanism, and you have to go over a proper tunnel otherwise.
Cisco. Actually, that's a similar comment to Jeffrey, that by putting an IPv6 header in front doesn't mean you're doing IPv6, because the forward and lookup that you do to send out the packet is based on the bit string. Yeah. Right? So you make it seem like V6, but it has nothing to do with V6 really. So if you want to carry V6, maybe it's better to do the non-MPLS encoding and take an ether type and put a V6 packet. So reverse the order, because now we have like a big header you need to go past to get your bit string, and you can put it in front of the V6 header.
Yeah, so Greg, as chair, I think what hasn't been addressed, at least in the presentation, is that we don't have label and cap in this environment, and we don't have an ether type yet, right? So we want to implement, to get something going. I think it's an easy way to get something moving, but you're right, this is not V6. In the same way that with, in the past, people try to wedge bits into the V6 header in some way, try and saying that's, encoded in V6. It's no longer V6. You're forwarding on the Bier header itself. So I think maybe the use case should be defined a little more detailed. May not have hardware support for Bier and cap. So there it is, the first issue. And in HomeNet is all 6, right? So very focused in that use case, then the solution seems to fit.
Yeah, you kind of almost removed my comment, but my comment to that was, I would not call it IPv6, I would call it slow path Bier processing, and things I can do with and then yeah, things I can do with various headers to pound the thing to software. You don't even need to do this. There is other bits in existing IPv6, IPv4 that will pound the packet to software. And as soon as you have it in software, there's nothing preventing software from having a configuration. Look, you may be getting Bier. So,
So Tony, please, I looked at router alerts, I looked at the header extension and so on. This is significantly simpler if you look at the state of no IPv6 stacks and chips and so on. Simply from experience, what is out there.
Yeah.
Okay.
Yeah, but at least we need to rename this to slow path Bier processing.
Tony P, I had a rebellion on my hand because I said slow path. People didn't historically know what that means. They really meant it's really slow path.
Yeah, because it is really slow path, because let's be real, like this will never be as fast as ingress replication. And I can ingress replicate the hell out of the inner router and I will still have a better performance than this will give me. So
Who here's read the
Like
draft? Got very little traction in the draft. Okay, is the intent here to look at adoption as a solution, as like a standard solution? I mean, it seems like this is transitional.
Yeah.
It could be just informational. It could be.
So call of adoption will hinge on the fact whether the Babel HomeNet guys show interest in that stuff. Because there is an open source implementation ongoing for Bier extension for Babel. And if they pick that stuff up, HomeNet doesn't have a multicast architecture, and that becomes inherent part, and it's a kind of a possibility to get very quickly early implementations, so people can play with this stuff.
Right, but Greg, Chair, but I would also say the same as, like I said, quick to get implemented, but I can't see this as being the end game in Babel.
So Babel protocol extensions are independent of that, right? But Babel is just a control plane. This is the data plane until we have an ether type and they get small router supports for special ether types or, our encapsulation and so on.
So then I'd encourage the draft to document itself as being a transitional solution.
Yeah. So, hi, Cisco. So in HomeNet, the fan out isn't very large, right? So we have another draft in the individual submission to encode the Bier bits into the IPv6 address itself. That might also be a simple way to get going, right? It's maybe simpler than this even.
Wasn't that done in Dallas?
Done in Dallas.
At the hackathon?
Exactly. Yes. Very good. You see, you need, what is it,
There's already
24 hours?
the implementation out there, open source.
Yeah.
and this is, you just hit on, Andrew Dolgano Nokia, you just hit on my point. If this is informational, is it transitional? We probably spend more time talking about it than it would be to implement this. Because it doesn't need interoperability, doesn't, like, transitional, informational, we're not going to be deploying this in networks across multiple vendors. It's hop by hop, by the way.
I'll let you go. All right. Good discussion. Thanks, Sammy. Next up is you again. This is flooding.
Yeah. Okay, the second presentation is for Bier flooding. Let's see the problem statement. It's a typical hybrid network. And from this, we know that different routing protocol runs in different region. And even static routing is used in some region. I'm sorry about, I forgot to write some region with static configuring routing. You can imagine it. So there are only tens of routers in every region. And even in some region, like the figure below, we know that there is only one hop forwarding in this network, in this region. So if we want to deploy Bier in such network, we know that from the existing technology, we can use IGP extension to advertise the beer node information. So, so we can deploy several beer domain in this network, and the border router must convert the beer encapsulation, like such as MR3, MR4, B1 to B4 must make the beer encapsulation conversion. So multiple beer encapsulation and decapsulation functions will decrease the efficiency of beer forwarding. Next, please. So we think that if we can merge several regions into one beer domain, so you think that this network is only deployed with one beer domain. So the beer encapsulation and decapsulation times will be decreased and the beer forwarding efficiency will be improved. But a new problem occurred. How to build beer forwarding across multiple routing regions? I forgot to draw a picture, draw a region with the static configuring network. So if we use the existed IGP extension to do it, we know that maybe we can do some conversion in border routers. It's also the MR3, MR4, B1 to B4. They must convert the information and advertise it. But it may be at some complexity in the border routers, but it can solve some problems. But if the region is running static configuration routing, then so there's no IGP protocol running in this region. How can we advertise the beer node information in this region? So next. So we'd like to use a protocol-dependent flooding mechanism. The beer node information can be flooded with a PIM flooding mechanism defined in PIM source discover BSR draft. And the extension may be aligned with OSPF or ECS or BDP extension, but some change will be made to adopt this function. And every node in domain build a beer forwarding plane according to the flooding beer node info and its own table to build the forwarding plane and without dependent of IGP or BDP routing computing. The FIB is the forwarding information base. You know that. Next, please. I think somebody will confused with this draft, so we make two clarification here. This draft do not want to replace the OSPF or ECS or BDP beer extension. This draft is just a supplement of routing protocol extension, especially in hybrid environment. And we know that beer eliminates PIM protocol states in core domain. But this draft is not backward to say, oh, you must use PIM in the network. We just use the flooding function defined in PIM draft to deliver beer nodes information. So without this, we can use another function to flood the information. In order to get the same result. So we use PIM protocol to build the beer forwarding plane. Do not mean that we will use PIM protocol to build multicast trees. So we will not use PIM protocol to build the multicast trees. So we have some discussion in the mailing list with Jeffrey, and we know that if some network is deployed with IGP, we can do the IGP conversion in the border routers. So maybe we can write another draft for the beer proxy to advertise the beer node information. And this draft, we think that we can provide a general way to achieve the result. Yeah, please.
Thomas Eckert, the draft doesn't give an example of, the most interesting use case example for this hybrid IGP routing is. Can you quickly explain one?
IGP, sorry.
You called this the hybrid routing domains, where you have multiple IGPs that are in some parts of the network connected to each other. The draft doesn't give an example. What would be the most interesting example why we should do this?
Please take the previous page. Yeah, back. Because the previous, because this network is used very widely. This network is used widely in China, and every region, we know that the figure above is also the core domain.
So wait a second. So this is a core network of a Chinese service provider.
Yeah, in some operators. Yeah.
And how does the unicast routing work? Is there redistribution configured between the IGPs, or? I mean, is there anything we can read up on this? I don't want to drag it out because Greg is kicking my back, but it would be great to understand because I haven't seen this. So
in the core network above, it runs ECS level 2 to advertise the information, routing information from every aggregation regions.
Well, let's say this. I mean, we can take it offline, right? If I'm the only one that hasn't seen this, I'll do it one-on-one. But if others haven't seen this either, I think it would be great to have some pointers to, an important use case example for this, where this is described, especially in the unicast side, because I'm thinking if there's redistribution between IGPs, why can't I simply also do redistribution of the BIFT information, the BFER mapping information between the IGPs?
Andrew Dolgan, Nokia. Yeah, I would like to understand use case too, because, okay, that's not true. This is core. 163 doesn't do this. 169 doesn't do it. China 2 doesn't do this. We actually have routers in those, so none of them has that. So maybe some metro, I don't know, somewhere. Chinese providers don't buy another provider, so they don't have that problem either. So I would like to understand the use case, because I would collapse like you're showing OSPF, like different OSPF domains, different ISAS domains, like multiple domains, multiple IGP protocols, and now you want to run on top of it. It just makes like something feels wrong to me here. So,
Humemit Goli, yeah, I guess in the same kind of idea, I want to understand, are the B1, B2, are the Bier edge routers, or the MR4 and MR3 and all those other guys can be Bier edge routers too?
Do you mean the border router in this draft?
Yeah, so on Bier domain 2 and 3, are those the Bier edge routers, and the Bier domain 1, they are just forwarding routers?
I'm sorry that I'm lazy, so I only draw 2 routers in the figures below. There's tens of routers in Bier domain 2 and Bier domain 3, and the edge router can be the other routers in this network. So if we want to deploy Bier in this network, the MR1 and MR2 and the other, I haven't draw it out the routers as border routers of the Bier domain.
I guess all I was trying to get at is that if we can make some kind of Bier hierarchy here, that in your domain 1, the Bier gonna represent the border routers, and then when you go in domain 2 and 3, then you can fan out the Bier based on domain 2 and 3. That could, scale Bier better between these IGP areas. But as of now,
IGP only the routing area of one Bier domain.
All right, so we're
Yeah.
out of time on this. It sounds like what we have, and I mean, the questions keep coming up, so sorry for cutting you off, Torres, but the questions are kind of going the same direction. What's the environment here? What are you doing for Unicast? Why are you looking at a solution like this? Is this transitional? Is this a static environment? So we need to better understand that. Maybe we take that list and we can expand.
I was going to make the leap of faith and saying this is a great use case, but there is going to be unicast, what's it called, redistribution, right, between the IGPs. So why not simply use,
Exactly.
redistribution of the Bier information between the IGPs? Why come up with a new scheme?
As I said, thanks, Torres.
Oh.
Yeah. All right.
Thank you.
Thanks, Andy. So let's keep that live discussion, that list. Maybe we can be rewritten in a way that better defines what they're doing, why they need the solution, and then we can take it from there. All right. Next then is TENCAP.
Hello, everyone. I'm Chuan Xiong from ZTE. And my presentation is about BRTE. The first one is BRTE encapsulation. This document proposes a set of extensions to Bier encapsulation. As you know, the Bier encapsulation, the Bier header can only carry one bit string. So I suggest the BRTE header contains more than one bit streams. The next. The modification is, as you know, the BRTE shows part of the architecture, the relation, and the packet format with Bier. But different with Bier, the BRTE, every bit position of the bit string indicates one or more adjacencies instead of an egress router. So that must be a root number over adjacencies from BFIR to all BFERs. So it may be under the Bier encapsulation, one packet is related to SD, BSL, and SI compilation. So in BRTE, the bit strings, bit positions of the all adjacencies passing through the BFIR to BFERs, the traffic engineering may be carried in more than one bit string. So so we just to extend the Bier encapsulation, and a new optional sub-TLV is carried in BRT header. The B bit indicates the BRT packet when it is set. Bitstream sub-TLV identifies the bitstring related information, and each bitstring sub-TLV corresponds to a particular combination. The last, please. Yeah, no, the last one. Yeah, this is the format of the bitstring sub-TLV. We gave two optional formats. The first one is the sub-TLV is carry the SD, SI, BSL information. The BRT packet will carry more than one bit string sub-TLV, and the N bit indicates that there are more than one or more bit string sub-TLV immediately preceding the TLV when it is set. The bit string is a variable. And that defines the collection of the adjacencies from BFIR to all BFERs. The second format is to set the BIFT ID instead of the SD, SI, BSL compilation, because they are mapped from SD, SI, BSL, and it is assigned from the computer, and it represents a particular bit index forwarding table. Yes, this is a example. BRT forwarding with bitstring sub-TLV is a simple example with two bitstring sub-TLVs. There are two BFERs, so there are two SIs, multi-SIs, SI is 0 and is 1. So we must split the bit string to two parts, and the packet will carry two bit strings. the number one, BFIR, the package, BFIR received the package with the 2-bit string subtitle width, and it will take lookups from the bit string subtitle width 1 and the subtitle width 2 to find the last hop. And the BFR2 is the same with the former ones. Here, the BFER1 and the BFER2, the package transmitted to the egress loss. And this is a simple example. Yeah, I finished it. Comments?
So did I read it correctly that, oh, Talsecker, that the BFRs would have to look simultaneously at all the bit strings?
Yeah.
And interpret them? Okay. And the idea is primarily to, I mean, instead of having 2 smaller bit strings, you could have 1 longer. So is the idea that each of the bit string would kind of be the maximum size that, I mean, I haven't worked with kind of forwarding plane for a long time, right? So I mean, you tell me if, you know, in your company, people have said that this would be a better way to do, you know, forwarding on more bits than having it in 1 larger bit string, or that, you know, if you max out the bit string lengths, that, you know, it would work well to have it in multiple. That I don't have that information.
Just one more. Go ahead, Ice.
Cisco. So actually, the same comment as Tool is just, let's say, the limit of, for example, 256 bits is because there's a maximum size that you can potentially read into memory and do forwarding lookup sum. So if you have to support actually add a TLV after that that you can read in, you might as well take a bigger mask of 512. That is a much simpler solution, and you know, and parsing TLVs in the data plane is probably not something we want to do.
And let me just add to that, as Greg, Chair, that's part of the architecture, right? Going to 6,
yes.
12, 1024.
No.
Okay, just a quick status on this too. The TE drafts as a whole have been taking the list for adoption. We are in a charter migration to make that. We'll have discussion in a bit, so let's just take that to the list.
Yeah.
Yeah. I mean, Toll Secretary again, I mean, I would be happy if, you know, we had one agreed upon encapsulation with a single bit field that can do TE, right? So that work certainly is still outstanding.
Okay, the last presentation is about BLT forwarding, and we co-worker with China Unicom, China Telecom. The document proposes a set of extensions to realize BLT forwarding. It is just a suggestion or implementation, including the assignment of the bit positions to adjacencies and the configuration of BIFT. The last, this is a problem with multiple SI. This problem was discussed in the mailing list. The problem is that if the adjacencies from BFIR to BFER is assigned for multiple SI, and the transit BFR doesn't have the given SI for BLTE packet, the BLTE packet may be dropped in that BFR as the figure shown. The SI split the domain into 3 parts. They cannot be transmitted from to the BFERs. So the last slide. Okay. Yeah. So the motivation of this draft is to solve the Bier TE forwarding because the encapsulation, the packet is related to SD-BSL SI combination. So the BFRs need to forward the packet based on the bit string. The bit strings of this adjacencies passing through the BFIR to each BFER must be assigned in the same SD, BSL, and SI combination to ensure the multicast flow to forward it to the BFER within the same packet. So the assignment of bit positions and the configuration of BIFT should be taken to consideration. So last slide, please. So we suggested the process for BLT forwarding. The step 1, the controller host will discover the network topology. The step 2, the multicast flow of lay to determine what multicast flow needs to be sent from BFIR to which BFERs. Step 3, the computer host calculates the explicit passes from BFIR to every BFERs. And step 4, the controller assigns the bit positions, including the SI, BSL, SI combination to the adjacency according to the explicit path and the assignment method and policy. And the BIFT is populated by the computer and incremental configured before the service deployment. The step 5, the controller and calculates the bit string according calculates the bit streams according to the explicit passes and the bit positions. The next step is once the BIFT and the bit streams was programmed into the data plan, then the BLT packet can be used to forward to the BFERs. So this is the process. Then the assignment of the bit position, we suggest assignment policy of the bit position as following. If we have, if the multicast flow is to send from BFIR to M BFERs, then we will calculate M explicit passes from BFIR to M BFERs. Then we will assign K sets of SD, BSL, and SI combinations, and the K is smaller than M, according to the assignment policy. Then we also suggest the two surface policy is that the more than one multicast flow will use the same resource like SD, BSL, and SI. There are two types. One of them is exclusive type. Then the two multicast flow may use the SD, BSL, SI combination exclusively. The sharing type is that the more than one multicast flows may share the same SD, BSL, and SI resource. Next one. Yeah. The next extension of the configuration for BIFT is that the BIFT is the one subdomain of BFR. Before it is the table indexed by SI bit position. So we extended this to the table indexed by BFT ID bit position. The BIFT is assigned by computer, and it is unique in the domain. It indicates the ID of the BIFT, and the BIFT type indicates the type of BIFT, including Bier and Bier TE. And the configuration of BIFT is not completed before the service deployment, but incremental configuration based on the requirement of the multicast flows. Last. So this is an example for the BRT forwarding. If we have a multicast flow 1 from BFIR2 to BFER1 and BFER2, we will first calculate the path explicit passes from BFIR2 to each BFER, like the blue lines present for example, we can assign the bit position from BFIR2 to BFER1. The parts we can assign the BIFT ID 1 to this parts, and the BIFT ID is 2 to the path 2. So this solution will save the bit position, and it will guarantee the SI is not multiple SI will not be dropped in the transit BFR. And the last slide, please. Thank you. The example 2 is based on the example 1. If the multicast flow 2 lead to be the bit position of the multicast flow 2 lead to be assigned based on the multicast flow 1, then the yellow lines is the path of the multicast flow 2. Then the BIFT ID is 2 is shared with the flow 1. We just need to assign the following adjacency. Then we will assign a new BIFT ID 3 to the path from BFIR1 to BFER2. So we split the bit string into 2 parts, and there are BIFT ID 2 and 3, and it is the same with the example 1. So this is the implementation of the BRT forwarding. Okay, comments are welcome.
So we're tight on time here. If you got comments, just hustle to the mic. Go ahead, Torles. Go ahead, hustle.
Yeah, Thomas Eckert. So I think the main question that I didn't quite understand is whether there were changes in any of the things that needs to be standardized, or whether this is kind of specific mechanisms and approaches on how the controller does it, in which case I guess it would be more an informational thing, right? Yeah. So a high level. And then the other one is, of course, the examples where you're doing the things explicitly for individual flows. I guess the whole goal is to have as little as per flow state, right? I mean, obviously you will always have for some group of states other bits that you need to do the traffic engineering. Is kind of the same softness that you have in segment routing, right? But I think the focus should be on optimizing that you have as little as possible state across as many as possible flows, right? So those would, I think, be the crucial goals.
Yeah. Okay. Thank you.
Sorry.
Okay.
Yeah, Rachel from Huawei. Can I ask a clarification question? Yes, you have two presentations. Did they have any solve the same problem or just solve different problem? Because my feeling is that your first draft, already can solve the problem across the different SIs. So
Yeah.
I'm
The
sure.
two drafts mainly solve the same problem, but I think it is the two solutions. Is the number one is the data plane, and the next one is the controller SDN network solution.
All right, got it. Thank you.
All right.
Yes, thank you.
Thanks. Got three more, and we've got to hustle. We're going to be some time at the end. We can actually get through this administrative stuff. So we've got now. Got extensions, right?
All right. Good afternoon, everyone. I'm Rachel from Huawei. I'm new to this area. Yeah, totally new to me. So, and this idea is pretty rough, immature, but I'd really to share this and asking for feedbacks, because your comments will give us if it's a right direction or not. Actually, it's quite similar to the previous presentations of the problems that we think BRT currently have. So, okay, the motivation here, and as we all know that BRT uses every bit position to indicate one or more adjacencies, which brings traffic engineering, which native Bier doesn't have. However, in our opinion, it has a scalability issue because we all know that the bit string size of one packet has limits. So one BRT packet can only travel through a small area of the network. Of course, it can be solved by sending multiple packets, but just illustrated in the picture below. But in our opinion, it doesn't look like the complete end-to-end traffic engineering. So we bring out this work. Next, please. Okay. Yeah. This is extensions in our work, our drafts. Yeah. Here, the first thing that we think the previous definition of SI is a set identify. We think it should be maybe better to be redefined as a segment area index in BRTE, so that the number of adjacent assigned each bit position, including one SI, is not larger than the value of BSL. Also, we define some rules should be have. Firstly, a packet is allowed to travel to multiple segment areas with different SI. So to do that, we should stack multiple bit string information belong to different SIs into the one packet header. But we cannot allow it as big as enough, as big as possible. So the total length of all the bit strings that the packet can carry is maximum BSL 4096.
So this is a good question.
Okay.
Greg, isn't the challenge that because this is multi-point, that you may enter multiple areas and you don't know which one to use when you get to the next area? I mean, this is a challenge we had in Bier inside of Bier, whether it's TE or traditional Bier, to stack it. there's no way to know what those, how many end destinations is going to be, and how many headers need to go there, and how many you need, which one you use when you get there. So I think we're kind of going down that same challenge path of scale, and stacking them, we've seen in the past, is not necessarily a viable solution. But we do have a couple different groups working on some scaling issues, and maybe
Yeah.
have you talked with them? Have you discussed this?
Not yet.
Okay.
Not yet.
So we're running tight on time, and we'll have this discussion come back that we've already had. So I would encourage the two groups get together, see if we've got a common problem space, we can work towards a common solution, take it to the list, and we can generate some interest of moving this work forward. Torley's got a question.
Yeah, no, Thomas Eckert. So, I mean, you have a redeeming grace in TE that you're really steering the packet. So you could use, bits from one bit string to indicate, well, now here, because you're evaluating this
How many do I
bit.
stack on there? How many domains
Sure,
am I going
sure.
to?
I'm not saying this is a whole solution. I'm just saying the problem may be easier than in Bier proper.
Okay, possible, right.
Yeah. So
So there's an extension field. again.
yeah, it's similar to that one, but we didn't define the detailed information for the bit information. We think it could be work like MPL's label things like if you travel through one segment area, you can pop up the useless one and then use the new one. And if you if the devices hardware has a problem to contain more to recognize the size of the bit string, multiple bit string information, he just could use the first one. It's just a very rough idea. So yeah, this is the point.
Right.
Yeah, yeah.
Just a quick last comment. Andrew Dolgan on OK. I would just want to underline what Greg mentioned a second ago. There are groups working on those statements. I think it's good if you guys start talking to people, communicate. This is a group that really works very well with multiple people working together, instead of like bringing just raw drafts without even talking to anybody. Even if you just talk before the meetings, gather people. It's well known who works on various areas. Highly encourage cooperation.
Yeah, okay, I understand that.
And Greg, speaking as chair, I mean, I encourage you, that's the best part of actually being present the week.
Yeah.
Try to spend some time this week to get together and then come out collaboratively.
Yeah, I totally agree. Sorry about this, but yeah.
It's great.
Yeah.
Thank you very much.
Thank you.
So another observation, and the timing is right to actually formulate what you guys think is the future direction we should be pushing into, because the charter will be probably under some discussions, right? And here the solutions are not even the most important part. It is formulating the problems worth tackling in the next generation are more important to formulate.
Okay. All right. That's,
All right.
yeah,
Thank
I'm
you
done
very
here.
much.
Thank you.
All right, next.
Good afternoon, everyone. I'm Yisong Liu from Huawei. Today, I'll introduce the solution for the MVP-based Bier P2MP. The purpose of this solution is to use the benefit of Bier to the existing P2MP MVP technology. Firstly, we can see the difference from the default topology and the P2MP topology. For the normal Bier, we use the, for example, like the IGP to extension to the Bier, and use the IGP default topology. And Bier will have the in the network we'll have the redundancy and loop, but in the specific multicast traffic, it will select the best path. But if we pre-build the P2MP tunnel, we can get a P2MP topology, and it will get more or less neighbors. And in this topology, we have no loop in the path. Next, please. So from the figure, we can see that in the topology and in the default topology, there are 4 has the link to the R3. And if we use the P2MP tunnel as the topology, like the multicast tree R1 as the root, and the branch has the R1, R2, R3, and another branch is the R1, R4. And so R4 has no neighbor of R3. So if we forwarding the Bier packet, like the 111 and 0, we just look up the bit string and not to change the bit string in the Bier header. If we use the P2MP tunnel as the topology, and we have selected the specific paths from the root to the leaf, so we may not use the entropy subfield for the ECMP. We can use as another way for the live protection, as we introduced later. Okay, this slide will show the optional forwarding procedure based on the P2MP. So we add a FBM on the NHFE for the Bier forwarding. For example, one R1 forward a packet with the bit string with the 1010 is forward to NHFE, and every NHFE will have the FBM. We will just end the bit string in the Bier header and the NHFE's FBM, and we can forward that. Okay, next. And this solution only make minor change from the P2MP MVPN. And for the normal P2MP MVPN, we use the IPMSI or aggregated IPMSI to carry many SG multicast traffic, and it will make more more bandwidth, and because we think that because the paren is only carried at the bottommost P, just the leaf PE. In the MVP P2MP solution, we make the paren carry out an every node from the topmost PE, and the change is that we only add a FBM on the P2MP NHRV, and the Bier header, the stack Bier header in the packet, and replicating to the P2MP NHRV to make the ending the packet bit string and the FBM. Okay, next. That's the definition change from the normal tunnel attribute for the P2M for the RCPTE P2MP and the MRDP. The change is that we add a BSL in the definition, and we define a bench of tunnels. That is similar to the ISI in the Bier. We can make yeah. Okay. Okay. Next. Okay. Next. That is similar with the MLD. Is that just use the OPEC value? Okay. And the previous, I mentioned that the entropy we can use as in the live protection, and we can use as a sequence number, and one forwarding the packet from the source to the to the R2 and R4, and it will impose the sequence number. And for the transit PE, it doesn't care about that, And in the egress PE, it will select to avoid the path failure. Okay.
Just quick one, Andrew Dolgan. Okay, I'm not sure if you read architecture draft and use cases draft. That a lot of we're doing for Bier is to simplify stuff, and the last thing we want to do is do more MLDP, RSVP, TE extensions and features. That I understand there are people who used to code that and who still want to code some more, but like, I don't understand that use case, and why would we add more stuff to LDP, more stuff to RSVP to do something with Bier that wants to eliminate those two?
We just wanted to use the existing technology and just change, make a minor change to use the Bier.
More doesn't mean better, and you're just doing more. So
Yeah, more isn't always better. One more comment, and we got to roll. Go ahead.
Sure. Human Bidgoli, I just want to clarify. I read the draft a couple of times, and I'm not sure at the end whether it's going to be Bier over MPLS or MPLS over Bier. How's the packet going to look at that? The packet that you are sending out, so is it going to be MPLS as a tunnel and Bier is on top of MPLS, or is it the MPLS on top and Bier at the bottom?
All right.
In the MPLS encapsulation.
Yeah, let's move this along. I mean, it's just definitely a challenge to really understand what we're trying to solve here. I think, like as Andrew pointed out, there's a schism between the architecture doc and the intent here. So I'd challenge you to go back and look at that stuff, take this off the list, bring some questions out, and see if we can get some response. All right, next and last, before we get to the real fun, 10, HTTP using Bier. Excellent.
Hello, everybody. Good afternoon. I'm Debashish Purkayastha and presenting this on behalf of my co-authors. So if you go to the next slide, please. This draft is in relation to the use case that describes HTTP level multicast. So just as a background, HTTP level clients benefit from the dynamic multicast group formation that is enabled by the Bier. And the server-side NAP creates a list of outstanding client NAP requests to the same HTTP request URI. And when response is available, Bier forwarding information is retrieved and used to send the HTTP response. So in this draft, we kind of elaborate this use case and introduce some requirements for a Bier multicast overlay. So in terms of requirements, we propose to supporting multiple FQDN-based service endpoints to exist in the overlay, and also FQDN-based service request at the network level to suitable FQDN-based service endpoint, and using the policy-based selection, and also must allow for multicast delivery of HTTP response and also provide direct path mobility. Next slide, please. So in the multicast overlay operations, we propose a function called path computation element, which is responsible for selecting the correct multicast endpoints. The result of the selection is a Bier path identifier, which is delivered to the NAP upon initial path computation request. And the path identifier is used for any future request for a given URL-based request. And so here these operations is elaborated more. HTTP request, say, is sent by an IP-based device towards the FQDN of the server defined in the HTTP request. So the client-facing NAP terminates the HTTP request at HTTP level, and then the server NAP at the egress terminates any transport protocol on the outgoing server side. Next slide, please. And on the server side, if no local Bier forwarding information exists, so the path computation entity or the function that was described earlier is consulted. which calculates the unicast path from the BFIR to which the client NAP is connected. And upon arrival of an HTTP request, the server NAP forwards the HTTP request as a well-formed HTTP request locally to the server. And if no Bier forwarding information exists for the reverse direction towards the requesting client NAP, this information is requested from the PC. And now when new client request or new client NAP request arrives at the server, the HTTP request looks is there is still any outstanding request. The client NAP is, if there is so, the client NAP is added to an internal request table, or all the request can be also suppressed from being sent to the server. And when the server-side NAP receives an HTTP response, the NAP consults the internal request table for any outstanding HTTP request, and then it retrieves the Bier forwarding information for the reverse direction for all outstanding HTTP requests and determines the path. So in terms of functionality, there are some protocol considerations, basically NAP to NAP protocol, NAP to PC protocol, and also overlay transport protocol for exchange of Bier layer information, the registration protocol to registration FQDN-based services, and also content certificate distribution protocol for HTTPS support. I think that's the functionality to support this HTTP multicast.
Go for it.
Andrew Dolgan, Nokia. So thank you first to chairs to schedule something more sane at the end, so we finish well. Can you point maybe to a little bit of documents how this works without Bier? Because it seems that you're trying to use Bier for something, which great, but I would like to a little bit understand the other, the existing thing, how it works before I can comment if what you're doing makes sense.
I don't think we could explain that here.
Okay.
Maybe if you could document that or point those people to the list so we can read that.
Okay, maybe we can discuss, offline.
This is for something like ABR video streaming to multiple live recipients, or is that?
Pardon?
Is this for something like more efficient?
Video ABR.
Yeah, for video ABR, is that the use case? Live video ABR?
Yeah, this is the use case that is already in the use case document.
Yeah, seriously, I mean, this is with a lot of other great, starting points, higher level up the first thing, right? So being in the bits and details of how it's implemented, that's.
Next.
Robert Rashuk, one question. So this is completely in the overlay. So why don't you use proposal which is already implemented and shipping, like from Pedro Edge Multicast from compute nodes, for example? It's already done.
One more.
Cisco. I did have trouble to sort of understand the bigger picture, but maybe I'm missing some HTTP knowledge here.
Not alone.
Okay, good. So you mentioned PC element, right, for path selection. Now, I think that would only work in combination with traffic engineered Bier, because you have a path, but that doesn't mean that you have routing state in the network itself. So is this strictly tied to Bier TE, or is there like Bier information in the network itself?
I think the gap here, I'm sorry to cut you off, we were like really tight on time, we dive to. I think the problem is that we don't understand what the existing solution does without Bier. So if we had that, I think we could then ask them more intelligent questions. All right, thank you very much.
Thank you.
One more. Bam. And back to 0. Quick status update. Look at this. Okay, we got stuff in the queue. We got one more that's almost in the queue. We've got the an RFC number. Thank you. That's 3 years from BOF to RFC in the forwarding plane. So I think that's substantial. Pat everyone's in the back, and let's continue to move this stuff forward. All right, so we have some other Shepherd write-ups coming. We have some IGP work to get published out. And then next is Charter. So Torless specifically, and those others who have who published some TE docs, that wasn't in our initial charter, so we kind of held off on that. But in talking to the ADs, I think there's a lot of support for going towards adding that to the charters and move forward. So the question is, standards track migration, keeping this thing open. This is the forwarding plane. I think we see a lot of different use cases coming up. We have some OEM work that's got to be polished as well. There's a lot of things still to be done here. What we've done is built a foundation. And now hopefully we'll have castles growing on top of that. So just from a room discussion here, who thinks this is work that should go through standards? And Andrew and I will be working on a draft in the next few weeks and move that conversation forward.
Yeah, absolutely. I think we should move it to standards, and more so, we should also actually show others how not lightly people are taking things like this, because I think we spent quite a bit of time and set a high threshold of moving something what started as experimental to standards.
Thales, did I overlook some, implementation experience report drafts?
Right, that's the justification draft. Is Andrew and I will be working on that.
Okay.
And it'll be to the list here hopefully soon. We want to get this stuff moving before the end of the year because, the holiday collapse and everything, and then we'll be running out of time. And Aaliyah's got some personal agenda she wants to get stamped off before she goes on to the big 80 cloud in the sky.
I'm gonna get slapped. What high standards?
Yeah. So Andrew, I mean, you said get the word out, like evangelizing the work from the list in some way. Do you have ideas how that would maybe form? What could we do? Any suggestions? I mean, we could throw a big IETF party. I don't know. How do we get the message out?
Sorry, how do we get a message for standards or for what?
Well, maybe I misunderstood your position. Like, you're saying getting the word to discuss the migration standards, or once?
No, I think the standard move is, I think, the question that's done. I think we put it to the floor few IETFs back. We worked on this. We've proven that we're not gonna take it lightly. So we raised the bar. We didn't say right away, yes, let's do it just because we want it. We brought the implementation, we brought vendors, we brought operators into the picture. We're doing now drafts that are driven by a push to introduce this into the networks, into real networks. I think it's really good. I think we need to recharter because there's a lot of very interesting work that's happening as well to continue that.
Yes, young lady.
Aaliyah Atlas. Thank you. You can't even see the gray in my hair now. Anyway, so I would like to recharter. Obviously, I have great aspirations to get the recharter done well before the next IETF. To do that is going to take some serious work from the working group. First, there's the document which Greg has promised me before, let's see, 2 weeks, you said, so well before Hanukkah starts, right? Excellent. I was going to say right after Thanksgiving, but that seemed a little harsh. But this is the draft that's addressing we have a good enough understanding of this, and it's catching on adequately in industry and for operators that we see it going forward. I mean, it's not a technology question, it's a business question, industry question. Get that document. We're going to try and move that through the working group faster than you have ever seen if people are happy with it. But that means you're going to have to review it. So, to go along with the presents for the holidays, you're going to want to have a good review of this because I'd like to have it done in January. That will give us time to recharter. And then once we've rechartered, we can do some status updates. Status updates do have to go through some process and last calls and telechats. We're going to have 5 documents or so, 6 documents that will need to be status updated. So we need to move.
Absolutely agree, but I also can read absolutely agree, but for those of you who stand far away from Aaliyah, you may not see the first label under her badge. Our team rocks. So I have nothing else to add.
Well, that's why I'm wearing it. Our team does rock. Thank you all very much. I mean, the work here is really good, and I personally was really excited to see the HTTP work because it's an indication that there's starting to be some more understanding of how this technology can start aiding in application level multicast and in a way that we just haven't ever been able to do. It's going to be really great. So beyond that, the TE stuff Greg talked about, I need to hear what other things should go into the recharter. I'm sure we'll have some discussions on the list because I know you're all excited now. Thanks.
Was it a real question or just
Yeah, we're 5 over, but keep going. We're having a great time.
Yeah. No, the actual, setting Bier bits from an actual application layer as opposed to a stupid PE device, right? That would be another area.
Absolutely. Well, I don't think there's anything in architecture that prevents that now anyway.
No, but we haven't gotten to the crazy point of bringing up the word API in this IETF thing for applications, and then, but that would, we had the use case in the data center in the end of last year, so got a little bit quiet around that. We'll need to see
Come
what
to the
troops
BOF
are.
in the morning.
Yeah.
There's a data center routing BOF in the morning.
Yeah.
Yeah, and I agree, and I second the stuff that Lia and Eckert said. Seeing that, and that's why I say glad to see that last draft after a few others, because now we're talking about some things that people are actually on the application layer doing.
So obviously, I'm not sure about whether this has to do with the routing in the data center, but more, if you look into all the distributed applications in the data center, right, where they basically are parallelizing across, multiple devices and need to get the same data to 5 or 6 adjacent
That
nodes.
goes in the BOF tomorrow. Yeah. Right. But these are the items to think about adding to the charter, or whether it's specific or broad, but you're all invited to contribute. Any more comments about the direction? Sounds like we've got fairly solid consensus. Okay, who thinks we need to keep the group up and recharter towards opening up for more solutions? Solid. Who thinks we should shut everything down and ship it? Nobody. Perfect. We're all in consensus once again. Holding hands, singing Kumbaya. Who thinks we need version 2.0 of a Bier? All right. Who's going to help pay for it? All right. We got a few contributors. All right.
More importantly, how are the hubs in Belgium this year?
That's it. Blue sheets. Who's got blues?
Who thinks that Bier is in better shape than the first version of PIM v2, right?
All right.
How many versions did we need of PIM v2?
That's low.
Excellent. Blue sheets. Who's got the blues?
Oh, I'm sorry.
Anyone see the blue sheet somewhere? Stand up and look on your seat. Maybe you're sitting on it. Anyone not sign the blue sheet? Oh, it's back there. Can you bring it up for us?
It wasn't intentional.